It might not be so obvious that in the middle of this beautiful field, some of the most interesting science is being developed. The Pierre Auger Observatory is a 3,000 square kilometer array of detectors that 17 countries and 300 physicists built to try to understand the origin of the highest energy particles that we've ever observed.
Cosmic rays are particles which arrive from the universe continuously on Earth. Right in this moment, through my hand, you have several per second. The one that we are interested in the Pierre Auger Observatory, have 100 billion times the energy of these normal cosmic rays that are passing through my hand. The problem is that it's very difficult to find an explanation of their existence. It's very hard to find a physical process that either generate or accelerate particles at this enormous energy. So what we try to do here is to find their origin. But ultra-high-energy cosmic rays are very rare. You would have to wait 10,000 years to have one landing on a baseball field. So this is why you need a giant observatory like the Pierre Auger Observatory.
The reason we use this area is because it has the perfect height. It's a very flat region, and the population is very friendly to us and is able to let us into their land to leave our detectors.
Nosotros somos técnicos electrónicos, Oscar y yo, y lo que hacemos es el mantenimiento del detector en el campo y que esté funcionando. O sea, años atrás lo que hacíamos era instalar la electrónica y ahora lo que hacemos es mantener y que el detector esté funcionando, o sea, que esté enviando datos de los eventos de rayos cósmicos que está recibiendo. Le llama mucho la atención el hecho de que hayan estos detectores en el campo, que no están conectados a nada, que tienen un panel solar, que tienen agua adentro. Les llama mucho la atención de saber qué es lo que para qué funciona, para qué es todo esto.
Well, the Pierre Auger Observatory is unique because it puts together two different detection techniques. One which is based on the measurement of particles at ground, so you have 1,600 detector tanks placed over an area of 3,000 kilometers. And you have 24 telescopes that look at the fluorescence light which is emitted by these ultra-high-energy cosmic rays in the atmosphere. So the two systems work together in this way. Once one of these cosmic rays arrives from the top of the atmosphere, it produces a shower of particles detected by the surface detectors. In the meanwhile, the shower produces fluorescence light, which is measured by the fluorescence detector.
The ground detectors measure very carefully the time of arrival of the particles. And you can imagine if we have two tanks separated by a mile and a shower of particles, it's really a flat pancake comes down. It'll hit this detector first and this one later. We measure the time difference and do a little trigonometry, and we have the direction of the particle.
The fluorescence detector is a telescope which concentrates the fluorescence light into a camera. Basically, you make a movie of what is happening in the sky, but it's a very fast movie because we make pictures each tenth of a millionth of a second. This is actually an image of one cosmic ray shower that has been recorded by the fluorescence detector. The signal that we measure is proportional to the energy deposited by the shower in the atmosphere, so to the primary energy of the cosmic ray. When you put this information together with the ground detector, we are able to explore the origin of this ultra-energy cosmic ray.
Nice, that's a high energy. Auger is finally reaching the point that we can look at where these particles actually come from. And it seems to be that they are coming from these huge jets coming out of the centers of galaxies that we call active galaxies. Right now we have about 30 events that seem to correlate with the positions of these active galaxies, which have a pattern in the sky that looks like the pattern that we're seeing. So we're starting to be able to peek at the beginning of these high-energy cosmic rays, which are much, much stronger than any accelerator we are able to build on Earth. So we're getting to the exciting point right now.
Creo que turísticamente a la gente le sirve mucho, le sirve mucho.
Eso ha ayudado al crecimiento de Malargüe, al conocimiento en el mundo de Malargüe, porque antes no era muy conocido, era un pueblo muy chico. Ahora ya se conoce, digamos, en todo el mundo.
Ultra-energy cosmic rays allow us to open a new window in the universe, a window that has never been explored before.
Connecting the highest energy particles with the universe as a whole is a very interesting quest for us, because we learn from both sides. We learn how nature can produce these particles, and we learn how probing these particles gives us new information about the nature of the universe.